SpaceX just confirmed Flight 12 is launching this month, likely January 30th or 31st, putting it on a collision course with NASA's Artemis 2 timeline. While Artemis 2's launch window opens February 6th, unresolved heat shield concerns could push it to March or April. This isn't just about two rockets racing to the pad. It's about two fundamentally different approaches to lunar exploration happening at the exact same moment. So, here's the real question. Which mission will actually prove more critical for getting humanity back to the moon? Let's start with where we are right now, because the timeline is tighter than most people realize. It's been almost 3 months since Flight 11 gave us that spectacular finale, plasma engulfing Starship during re-entry before both vehicles exploded in the Gulf. But SpaceX hasn't been resting. Every single day since then has been spent preparing for something significantly more important. Ship 39 was fully stacked back in November and should have been testing weeks ago. Then Booster 18's LOX tank ruptured during tests, and the suspected culprit was the COPVS, those composite pressure vessels that regulate propellant flow. When something like that happens, you don't just fix one vehicle. SpaceX pulled Ship 39 back into Mega Bay 2 and removed all its COPVS for inspection and possible replacement. This kind of work happens behind closed doors for good reason, and it added weeks to the timeline. The last confirmed sighting was January 2nd, when the bay doors opened briefly, revealing Ship 39 wrapped in dense scaffolding during heat shield work. This matters because SpaceX isn't just doing routine maintenance. Since Flight 5, they've been developing new tile versions with over 18,000 replacements and a critical secondary ablation layer. For Flight 12, they're using what engineers call a crunch wrap, a soft material wrapped around each tile to seal the gaps. During re-entry, superheated plasma searches for any pathway through the heat shield to reach the stainless steel underneath. Even millimeter-wide gaps can become catastrophic at those temperatures. The crunch wrap creates a flexible seal that handles thermal expansion without creating those deadly pathways. What makes this approach smart is that Ship 39's first flight prioritizes stability testing over pushing absolute limits. If it reaches suborbital altitude successfully, that validates months of design work. But SpaceX is also testing the Raptor 3 engines under full flight conditions and validating the new raceway system that organizes propellant lines and electrical cables along the exterior. Those raceways are external housings running from the main tanks down to the engines, protecting everything while making maintenance easier. It's unglamorous engineering work that actually makes the difference between a vehicle that flies once and one that can fly reliably. Right now, Ship 39 needs its scaffolding removed so it can roll out to Massey's for cryogenic testing, expected this week. After that validates tank integrity, it returns to Mega Bay 2 for its 6 Raptor 3 engines to be installed, then back to Massey's for static fire testing. This entire sequence takes approximately 3 weeks, putting Ship 39 flight-ready around January 25th, with launch possibilities opening January 30th or 31st. The more complex challenge is Booster 19, simply because of scale. 33 Raptor 3 engines versus 6. Before B-19 even rolls out for testing, SpaceX is validating Ship 39's aft section on Test Tank B 18.3 using the can crusher, a hydraulic device that simulates engine thrust by compressing the tank structure. This tests the hot staging ring, that critical connection point where explosive separation happens during flight. Getting this data first lets them identify weaknesses before committing the full booster to testing. Once that data comes back clean, B-19 rolls out for its cryo test, also expected this week. Then comes the demanding part, installing all 33 Raptor 3 engines. Each engine must be precisely aligned, connected to propellant feeds, and integrated with thrust vector control systems. After that, B-19 heads to Pad 2 for static fire testing, which simultaneously validates the booster and the brand new infrastructure that's never been tested under full operational conditions. SpaceX expects all testing complete by January 27th. We know they're serious about late January because the FCC's Special Temporary Authorization Consumers covers January 23rd through June 28th, the radio frequency license they need for communication with both vehicles during Flight 12. Now here's where this story gets genuinely interesting. On January 31st, NASA announced that platforms inside the Vehicle Assembly Building have been pulled away from SLS and Orion. For a program that's faced years of delays, seeing actual progress toward rollout represents real momentum. What changed? Jared Isaacman's leadership at NASA and intensifying geopolitical pressure as China's space program advances. That pressure is translating into concrete commitments. NASA's launch window opens February 6th and extends through spring, closing no later than April 2026. But technical reality complicates political optimism. After Artemis 1, NASA made a controversial decision. They chose not to replace Orion's heat shield. Instead, engineers adjusted the re-entry trajectory, shortening the skip phase to reduce time spent in extreme heating. Here's what went wrong during Artemis 1. Orion's Avcoat heat shield is supposed to wear away evenly during re-entry, carrying heat away as it erodes. That didn't happen cleanly. Parts cracked and broke off in chunks rather than ablating smoothly. The capsule came back battle-scarred with irregular erosion patterns that weren't predicted. That was an uncrewed test. With astronauts aboard, those same heating dynamics become a crew safety issue NASA cannot afford to get wrong. NASA conducted over 100 tests and traced the problem to gas buildup linked to the original trajectory. By shortening the re-entry profile for Artemis 2, they believe they've addressed it without complete heat shield replacement. Life support and battery concerns have reportedly been resolved. Even so, February 6th should be viewed as a target, not a commitment. Any additional data review, any late emerging concern, any unfavorable weather could, and probably should, push the schedule into March or April. That's not criticism, it's reality when dealing with crew safety on a spacecraft that's never carried humans before. This creates the real tension worth understanding. If Flight 12 launches January 30th or 31st as planned, it will almost certainly beat Artemis 2. But beyond simple timing lies something more significant. These missions represent fundamentally different philosophies about reaching the moon. Artemis 2 flies on hardware that took decades to develop and costs billions per launch. SLS and Orion are magnificent engineering, but they're products of a previous era. Slow development, extensive ground testing, minimal flight rate, limited reusability. Isaacman has been notably direct about these limitations, pointing out that Orion is roughly 20 years old and has never carried crew, while highlighting quality control concerns with SLS components. Flight 12, by contrast, is part of rapid iteration, where flight testing generates data for the next design improvement. SpaceX has flown 11 Starship missions in less than 2 years. The Raptor 3 engines on Flight 12 didn't exist when Artemis 2's hardware was being assembled. The heat shield improvements Ship 39 will test were developed from data gathered just months ago. Here's my perspective on what this actually means. Artemis 2 will prove humans can safely travel to lunar orbit in a vehicle designed from the ground up for deep space crew operations. That's valuable data that cannot be obtained any other way. Flight 12 continues validating Starship's role as the human landing system for Artemis 3, testing propellant management, engine reliability, and re-entry performance that makes lunar surface missions possible. We probably need both missions to succeed. The real question isn't which launches first. It's whether NASA's legacy systems can keep pace with the rapid evolution happening in commercial space, and what that means for sustained lunar exploration over the next decade. Because right now, the gap between these two approaches is widening faster than most people realize. So here's what we're looking at. Flight 12 launches in the next few weeks, likely beating Artemis 2 to the pad. Both missions matter, but they represent two different futures for space exploration. One proves crew safety in deep space. The other validates the infrastructure that makes sustained lunar operations economically viable. The gap between these approaches is widening fast, and that's the real story worth following. If you found this breakdown valuable, hit that like button and subscribe to New Space Review to stay ahead of what's actually happening in the space industry. Drop your thoughts in the comments about which mission you think carries more weight for the future. Thanks for watching. For more on SpaceX's infrastructure expansion and what it means for this timeline, check out the video on screen now about their 5-pad strategy.